In example number 9, we want to be able to find a solution to a dependent system of linear equations. So let's find the solution to the system of equations using the addition method. The first equation is x plus 3y equals 2. The second equation is 3x plus 9y equals 6. So we're going to write that in order. Now, with the addition method, we want to eliminate one of the variables by adding the equations. In this case, let's focus on eliminating x. Now, we can also eliminate y. It doesn't matter which one you choose to do. So if we multiply both sides of the first equation by -3, then we will be able to eliminate the x variable. So the first equation, we're going to multiply by -3. So we're going to multiply every term by -3. So we get -3x. -3 times positive 3y is minus 9y. And -3 times 2 is -6. And then we're going to leave this the same, which is the reason why we're writing the same. So therefore we have the following. So when we add -3x with 3x and we add -y plus 9y, we get 0 on the left side. So again, as I stated before, you want to follow through. Then we have -6 plus 6 on the right side, which is 0. Now, does 0 equal 0? Well, it's true, because it does. So that's a true statement. Now, we can see that there will be an infinite number of solutions that satisfy both equations. Now, we also need to pay attention to this because we'll be dealing with this in the next couple sections. Now, if we rewrote both equations in slope-intercept form, we might know what the solution would look like before adding. So let's look at what happens when we convert the system to slope-intercept form. When we have x plus y equals 2, we're going to subtract x to both sides. And then we're going to divide by 3. So we're going to get y, which is equal to -1/3 x plus 2/3. And if we do the same thing with the second equation, we're going to subtract 3x to both sides, and then we're going to divide by 9 and then reduce. And we end up getting y, which is equal to -1/3 x plus 2/3. So what you notice here is we get the exact same line. And that's the reason why we get a true statement. Now, in order to write a general solution to the system, since we solve for y and the right side is in terms of x, we would say that the solution would be the first order pair, which is x. And then what we solved for, which was y, would then be the y coordinate in terms of x. And then you can see here on a graph that they're both the same line.